Okay, let's check this question out. Let's start. So first of all, we knew that this is an equilibrium. Okay. And we knew that there were two strings that were, holding this box with a weight of 7.5 Newton in place. Two strings, T1 and T2, but they were both acting at different angles. And although it was not really clearly stated in the question, I wrote that down very explicitly that T1 is not equal to T2. These two are not the same forces. It's very easy to assume that T1 is the same as T2, but that's not really the case in this scenario, right? And that I made sure that you did not make that mistake. Okay. Now, how do you solve it? Let's check. Aris, what did you get as your answer?
I got T1. I
Hmm.
got T1 as 5.83 and T2 as 4.89.
T2. Okay. Okay. And Hania, yours as well. Hania, you made a slight mistake, and we'll check what that is. Okay. So I'm not sure whether your answer is right, Aris, but let's check. So let's solve it. So first of all, in
Okay.
this diagram, we know that it's equilibrium. Okay.
Okay.
Equilibrium means that all vectors, or you could say all forces in every direction are balanced. Okay. Now, if they're balanced, that means all the horizontal forces are balanced. Horizontal forces are balanced. And that means all the vertical forces are also balanced. That's a very, very important point. Okay, now let's check. So if you have this box, okay, let's talk about first the vertical forces. Okay. So the vertical forces, if they're balanced, that means that the only vertical force I have at the moment is 7.5 Newton downwards. Okay. And I have two vertical forces, right? Why? Because if this is T2, T1, right? There must be a vertical component of this T1 vector. And I know that to be, if this is 40 degrees, right? Then that means that this must be T1 sine 40, right? So that means the upward or vertical component of T1 is basically this. It's T1 sine 40. Okay. But now I have the other vertical force as well, right? I have T2 as well. Now T2 is in this direction. It's going a little bit up and it's going a little bit to the left. But if I were to only write the vertical component of this force, then that would be upwards, and it would have T2 sine 50 as its magnitude. Okay. Now, according to this equilibrium rule, all the vertical forces must be balanced. I am only talking about the vertical forces at the moment right now. Okay. So that must mean that T1 sine 40, okay, plus, why? Because they're both in the same direction, I can add them together, plus T2 sine 50, they will be equal to 7.5. Why? Because if up and down are equal, that means that the upward forces are equal to downward forces, right? That's the only way they can be balanced, right? Just like if you push a box like this, for example, if you push a box like this, if this is 3 Newton, this is 7 Newton, but what if someone else is pulling backwards with 10 newtons, right? They're both equal, right? 3 plus 7 is 10. So 10 minus 10 is 0. Okay. So that means if you have the vertical forces are balanced, that means the upward forces must equal to the downward forces. So the problem is that I cannot find either T1 or either T2 from this example because I have two unknowns. I don't know what T1 is. I don't know what T2 is. It would make my life much easier if I knew that T1 was equal to T2. Then I could just, use T over here. I could just use T over here and then I could find for T. But I don't have that. I have a bigger problem that I have two unknowns. Yes, you use this method or did you do something else?
Yeah, I did this.
You did this? Okay. Okay. So, Anya, what you did was you considered this to be separate. You considered T1 sine 40
But
equal to 7.5, and then you considered separately T2 sine 50 with 7.5. That would be wrong. Why? Because they're in the same direction. You've got to consider both of these, right? You've got the upward forces this one, and you've got the downward forces this one. So total up forces should equal to total down forces rather than individually. What you did was kind of like you considered that there was a person pulling up with 3 newtons, there was a person pulling up with 7 newton, and there was one single person pulling down with 10 newton. Of course, when you take the resultant of these, you're going to add these and then subtract from 10, right? You can't really do 7 minus 10 separately and then 3 minus 10 separately. That will give you, some weird answer. That's not exactly what's happening, right? Because the 10 newton force is only one time, so we can't subtract like 2 times. Anya, did you see what your mistake was
Yes.
for this part? But this is this is only like one part of the question. Now we'll do the next part. Yes, Aris, what were you saying?
What I was asking is, would T1 sine 40 and T2 sine 50 be equal though?
What do you mean?
Can
Uh,
they be equal?
these two?
The two.
No,
Yeah,
no, no, not
T1 sine
necessarily.
40 and T2
No,
sine
not
50.
necessarily. Not necessarily.
Oh,
They cannot.
okay.
They cannot always be equal.
Okay.
It might be equal. It might be equal if they were both the same T force and they were both acting at the same angle, but no. The original force is also different, and the angle that they are acting is also different. So we can't really say that. Huh? The only thing that we can say are equal is we can say that the sum of both of these functions is equal to 7.5. That's the most we can say at the moment. But if we have two unknowns, how do we find out the value? Okay. We have another horizontal part of the question as well, right? We haven't touched that yet. So what is the horizontal forces? The horizontal forces, I only have just two horizontal, right? There's one to the right. So you've got this one as T1 cos 40, right? So this is T1 cos 40. And I've got one force to the left, right? So this is going to be T2 cos 50. Okay. So I know that if it's an equilibrium, all forces should be balanced in every single direction. So all the horizontal forces must be balanced. So that should mean that the left should equal to the right? Or you could say that the sum should equal to 0. So T1 cos 40 should equal to T2 cos 50 if they are balanced. Okay. Now this provides a really good gateway for me. What if I were to write one of these equations in terms of T2? Can I say that T1 is simply just T2 cos 50 divided by T1 cos 40? Yes, with me so far?
Yeah.
Yes. What did you do, Aris? Did you do something else?
No, I did something completely different. Actually,
Okay.
got it completely wrong.
Okay. So, do you see that I have written T1 in terms of T2 over here? Okay. Oh, I've got extra T1 over here. Okay. What I did was I just took cos 40 on the other side. Now, do you see my original for the vertical forces? I can find T1 I can get rid of one of those over here. Now, for this vertical equation, can I substitute this T1 over here? Yes. So instead of T1, I am just going to write,
Oh.
what? Wait 1 second. Yes. So instead of T1 over here, I can simply just write T2 cos 50 over cos 40, right? So I replaced it over here with T2 cos 50 divided by cos 40. And then, the original equation. Do you see that now I have reduced it out to one variable equal to 7.5, right? Do you see how easy my problem became? I can do it the other way around as well. I could do it like this as well. I could make T1 the subject over here, and then I could plug in T1 over here. That would also give me the equation. So I simply just have to substitute somewhere, somehow, that I get rid of the other variable. Okay. Now, do you see that in this equation, I only have T2. So that means I just have to add all of this stuff together and I'll get the answer. So let's find out T2. So if I were to find out T2, first of all, let's do T2 cos 50 divided by cos 40, and then plus T2 sine 50 equal, no wait, equal to 7.5. Okay. So what do we do? What do we do? What do we do? I think I could take T2 as common over here. Can I factor out T2? If I were to factor out T2, this would become cos 50 or cos 40 plus sine 50 equal to 7.5. Right? So that means this is going to give me some multiplication number. Let me check. So this is cos 50 divided by cos 40 plus sine 50. This comes out to be 1 point cos 50 over cos 40 plus sine 50 equals to, this comes out to be 1.605. Okay. So that means T2 multiplied by 1.605 is equals to 7.5. So that means if I were to take T2 on the other side, sorry, 1.605 on the other side, this becomes 7.5 by 1.605, which comes out to 7.5 divided by 0.605, and that gives me 4.67. 4.67 Newton is T2. And that's, ladies and gentlemen, T2. But we still have T1 to find as well. But T1 is pretty easy to find. Why? Because now you have this expression, right? You already know what T2 is. So that means using this expression, you can say T1 is equals to T2 cos 50, right? That's already given to you. Divide by cos 40. You already T2 is, so this just becomes much easier. So T2 we figured out to be 4.67 multiplied by cos 50 divided by cos 40. So this turns out to 4.67 multiplied by cos 50 divided by cos 40. And T1 is 3.91 Newton. And that's how we figure out this question. Where T1 is not equal to T2, it makes things much more complicated and weird and challenging. And you've got to, use a lot of mathematics and stuff. Yes, Ariz. Did you have even the slightest idea it would take this much effort to do this?
I mean, I understand
Hmm.
how it is, but I just never put the cost values. I never use the cost
Hmm.
values.
You did not use the cost. How can you not use the cost values? Because you have to use the cost values to break them down into horizontal and vertical components, right? You can't do it any other way.
I
Because
just use
the
the sign values.
no, you need to use both
And
of
then
them.
the thing is, I assume that like T1 sine 40 is equal to T2 sine 50.
No, we can't do that. We can't do that. The only thing that we can assume in this case is that for the horizontal components, we know that right should equal to left. So we can say that this value should equal to this one, but we can't say it for this one. Why? Because there is a force of 7.5 Newton that's acting as well, right? Okay.
Yeah.
Now let me zoom out and check whether our answer is right as well. The working is absolutely right. Let me see if we did it all right. T1, yes. Okay. So we plugged in T1 over here. Yes. So, oh, we missed one thing. We missed one thing. We did one thing wrong, guys. So we, instead of, we replaced the T1 over here. We replaced it perfectly right. But we missed the sine 40 over here, sadly. So we're going to have to do it again. Okay. Now, what I'm going to do
Oh,
is I am going to erase this. Okay. And I want you to try this question again. Okay.
okay.
I'm going to give you 5 minutes. Okay. I've done the working for you. Do the question again because it's a really, really important question. This question, I guarantee you will not have a problem with any of the vector questions. Okay, Hania, can you do it?
Yeah, I'll try.
Okay. Try it on your own now. I've shown you how to do it. Now let's see if you can do it on your own.
Sir, I'll just go to the washroom.
Okay. Yes, Hani, are you done?
No, I'm still doing it.
Okay. Yes, Ariz, are you back?
Yeah, I'm back, but I'm not.
Okay. Let me know when you're done.
So what were the answers again?
I am not sure. The answers that we got were wrong because we missed one step.
Yeah, because I got different answers and I thought I got it wrong.
Okay, that's fine. We missed one step and that's why we had a slightly different answer. Okay. Are you done?
Yeah, I think so.
Okay. Yes, Anya. Are you
No, I'm getting like a really odd value. It's like in the hundreds.
in the hundreds? Okay. It shouldn't be hundreds. Why? Because
Yeah.
the weight is 7.5, so it should be like somewhere around that value. Okay, let's check. So again, if I again, because this is like a really important example, this single question is equivalent to solving like 10 questions for vectors. This is a really good one. And it will develop your mathematical skill as well. Okay, so we know that the horizontal forces and the vertical forces are. What are the vertical forces? For this part, you've got two vertical forces. You've got T1 sine 40 upwards, and you've got T2 sine 50 upwards. And there's another vertical force downwards, which is the weight 7.5 Newton. So I know these two should be equal because of the word equilibrium. So that means if I add up the upward forces, T1 sine 40 plus T2 sine 50, they should both equal to 7.5. Okay, I'm going to spend less time explaining this time. Then now the vertical forces, sorry, the horizontal ones. The horizontal one, there is one which is T1 cos 40, T1 cos 40, and they should be the horizontal left one, which should be T2 cos 50. Okay, these two should be equal as well horizontally. So T1 cos 40 equals to T2 cos 50. Is that right? Okay, yes, that's right. Because now I have like two unknowns in either of them. It's easier to solve them by substitution method. Okay, so I think it would be easier to, let's substitute T2 in this case. So let's substitute T2. So let's say T2 is equals to T1 cos 40. There's multiple ways you can do this. Divide by cos 50. I took cos 50 on the other side. Okay, so I've substituted T2. Okay, so this was equation 1. This is equation 2. And I'm going to take the same equation 1 and I'm going to substitute instead of T2, T, this value I'm going to substitute. Okay, so that means T1 sine 40 plus, instead of T2, now I'm going to write this value. So that is T1's cos 40 divided by cos 50 only, but there was a sine next to this as well. There was a sine 50 as well next to T2. So sine 50 should equal to 7.5. Since now I am only one variables, you could have also made like T1 subject over here and then solved instead of T1. Okay. So if I add these two together, first of all, let's make this much simpler. I can take out T1 as a factor. So T1, if I factor out T1, then this gives me what? Sine 40 plus cos 40 multiplied by sine 50, right? And then I have this being divided by cos 50 as well, right? So this is this entire term. You can, if let's make your life much easier. Let's get factoring stuff and let's just solve this part as 1 and see what we get as a decimal. So cos 40 multiplied by cos 50 divided by cos 50 and then divided by cos 50 and sine. Okay, 0.91. So this is T1 sine 40 plus T1 into 0.913 equal to 7.5. So, okay. Now take like T1 common, or you could, just you can find out the decimal value for sine 40 as well. So sine 40 is 0.64. So T1 into 0.64 plus T1 into 0.913 equal to 7.5. Now you can take it common. So T1 common 0.64 plus 0.913 should equal to 7.5. We're just doing a lot of maths, guys. So T1 is equals to 7.5 divided by the other value that we wrote on top. So 7.5 divided by, the next part won't require this much working because we've already figured most of the part out. 0.64 divided by plus 0.93, 7.564. Okay. Okay. So whatever this was, this came out as 4.83 Newton. So this is T1. Now I figured out what T1 is, 4.83. And if I find out what T2 is, T2 is simply just going to be this value. Now, because you already have T1, that you can substitute this as this. And you already know what T1 is now. So this becomes much easier. So 4.83 multiplied by cos 40 divided by cos 50. So answer multiplied by cos 40 divided by cos 50. And here it is. T2 is equals to 5.7576 newtons. Okay, this is like accurate up to like at least 2 decimal places. Even if you get, like a very close answer, like let's say 5.95, that's way too off, right? Because, the value should not vary by that much. If you get like 4.83 and the answer is actually 4.83 something, but if you get like 4. I don't know, 7.6 or 4.91, they're way too off. Why? Because the values cannot differ by that much. If they're that much, that must mean there's something wrong with the working and you somehow missed a sign or some kind of addition, subtraction somewhere. So that's why the answer would be wrong. You would get some marks, of course, out of 4, you might get 2. But if you want to get all 4 marks, you've got to make sure every single step is right in your working. You've got to make sure the answer is right as well. Okay. So that's how we got this answer. Yes, Aris, did you get that answer? Or did you get something else?
I got the same answer, except I got 4.82 instead of 4.83.
That's fine. That's close. That's close. But it
And I
can be like 4
also
points.
instead substituted, I substituted like to
That's
find
fine.
out T2 first.
That's fine. That's fine. You can do it either ways. I did it this way because I knew that you did it, the other way. So I can do it like this as well. It's up to you, whichever way you want to do it. Okay. Isn't it amazing how we can use maths to figure out so much stuff? That's amazing, man. Okay. Yes, Hania, did you figure out where you went wrong?
Yeah, I realized.
Yes. What did you do wrong? Where did you mess up?
When you said like we missed out like the sign, I thought you were talking about like the sign, like positive and negative. So I started
Oh,
like messing around with like the actual signs.
what do you mean? Like where sign?
Like I thought
Oh,
like direction
we
wise.
missed out sign. So we missed out sign
Yeah,
50. Okay,
yeah.
okay. That's why we missed out the
And
sign part. That's why we got it wrong in the previous. Although our answer in the previous attempt was very close, but it was not the right answer because that sign 50 could only things so much. It would not make your answer by 100 off. It might make your answer vary by 0.5, 0.3 something, but it was still wrong because we missed that single 50. But this time we included
also
it. Hmm.
one more thing,
Hmm.
when we add up like both these like T1 and T2,
Hmm.
why don't they like equal to 7.5? Isn't it supposed to be like equal?
Because that's a good question. So we found out T1 to be 4.83, 4.83, right? And we found out T2 to be 5.7. Okay. They are not supposed to be equal. It's the vertical components of these 4.83 and 5.67 that should equal to 7.5. Why? Because this is not a straight vector. This is an angled vector. It's an angled vector, right? So that's why they're not equaling to 7.5. But now you can try it as well. That means if you have this as 4.83 and you have this as 5.76 Newton, okay, and you have this force as 7.5 Newton. Now, because they are at a different angle, they don't have to be equal, okay? But their vertical components have to be equal, right? So what would be the vertical components of this one? It would be 4.83 sine 40. Let's check. Sine 40. Okay. And what would be the vertical component of the left one? That would be 5.76 sine 50. Okay. So that means 4.83 sine 50, sine 40 plus 5.76 sine 50. These should be equal to 7.5 rather than the angled one, right? Because if you remember in our box example, if you have 5 Newton like this and 5 Newton like this and 10 Newtons like this, does this mean that they are both equal? Does this mean that they're in equilibrium? Yes, Hania. Can we say that these are
No.
in equilibrium? No, because they're not at the same angle. So we can only say that if they're equal, we have to find out their vertical components. If they're equal, then that's good. Okay, that must mean that, they're in equilibrium vertically. So you can check this out. Try calculating what this comes out to. This will absolutely come out to 7.5. If it doesn't, that means we've made another grave mistake in our calculations. 4.83 sine 40 plus 5.76. It might be off by a little bit, but that's fine. Sine 50. That comes out to roughly 7.51 Newton, which is like very close. Okay. So it is
Yeah.
equal to 7.5. We made a lot of rounding offs and decimals in our calculation. That's why it's 7.51. But if you stick with the sine and the cos, our answer would have been even more accurate. But because of the generalization of the cos 40, sine 40, and decimal to make our life easier, that's why a little bit off. Okay. Perfect. And you can do it with the vertical, you can do it with the horizontal components as well. You can plug in T1 over here and you can plug in T2 over here, and you will check the value of them is absolutely the same. Let's do that one as well. So 4.83 cos 40. Can you check? And can you check 5.76 cos 50? Check. They should be equal. Check what the value is. Can you check?
Yeah, they're equal.
They're equal. What value are
Yeah.
they coming out to?
One is like 3.7 and like one is around 3.6.
3.7 and roughly 3.7, right? So they're both
Yeah.
equal. So that's how that's how we break this question into part. You're hopefully now able to better see what is happening along all of these vectors. How do you add the horizontals? How do you add the vectors? How do, all of those fit together? I'm sure you're able to see more than the numbers now. Perfect. Okay. Yes, Ariz. Does that make sense? Do you see how all of the pieces fit together? Cannot hear you, Ariz.
Yeah.
Yes?
Yeah.
Okay. Okay, great. Let's just do one last little question. Hopefully not as long as this. This is much easier. Okay, this one. I'm sure you will be able to do this much more quickly. What you've got to do is, you've got to find out. So let me just describe this instrument to you. This is a block of weights that's being hung down by these two strings. This string is providing a force of 8 newtons, but at an angle. This force or this string is providing a force in this direction at an angle of 69 degrees at 6 newtons. So 8 newtons at 44 degrees, 6 newtons at 69 degrees, and T3 is being hung down. So it says that they are all in equilibrium, right? The weight that is hanging is at rest. That means that all forces are balanced, right? In every single direction, horizontally and vertically. Okay. The question is find weight, of blocks hanging. Very similar question, but you won't have to do that much working for this one. And you already know the forces as well. So it's going to be much easier. It shouldn't take you like more than 4 minutes or 3 minutes. You may start solving now. You can assume that this is, your horizontal value. You've got to find out this weight. In the previous example, you had only been given the weight and you had to find out T2 and T1. But now you've been given T1, T2, angle given. You just have to find out the weight. This is a much easier example. This would be only worth 2 marks because this is even less than half of the working.
Okay.
And you do not have to draw a scale diagram. You have to do it resolving. Last question. The quicker you do it, the quicker you're free. In the next class, what we'll do is we'll hopefully start projectile motion. That's basically curved trajectories, a combination of both horizontal motion and vertical motion. And vectors will become extremely useful in the next chapter for projectile motion because it is mostly vectors.
Wait, sir, so whenever the angles are like inside
Hmm.
towards the vertical normal, then like the vertical component would be cos, right?
Yes, if you're taking this to be your angle, then this would be T2 cos 44. And then this would then be T2 sine 44, right? But you could also subtract this angle from 90 and then you could find this angle, whatever that is. Okay.
Okay.
So you can do that. And then you can find out then this, this would just be your regular T2 sine, whatever that angle is. And this would be nice. This is cos. This would be T2 cos, whatever that theta is. And this would be T2 sine, whatever that theta is. But that would be for that theta. You cannot say that this is T2 cos 44. Why? Because the angle for over here is different, angle for over here is different. It's just a different way of looking at it. The answer will be the same either
Okay.
ways.
Sir, for this question, do we only have to find like T3 or like
Yes, T1 and
okay.
T2 is given.
So
You
we
see
only
6.
find T3.
Yes, you've already been given 6 Newton and 8 Newton. Everything is given.
Okay.
This is a much smaller question, very, very small. In fact, it should like take you 2 minutes at best.
Wait, so you don't even need to like find out so you don't need to find out the horizontal.
Nope, nope. Because the only other force that's acting is the weight, right? It's vertical. So the horizontals would be. There's no point in doing it in this case
Oh yeah.
because the force that you want to find out is in the vertical region. So like you only need to deal with the vertical region at this point.
I got 7.90 newtons.
Okay, let's check. Yes, Aris, what did you get?
I was still doing it. I'm almost done. I'm just calculating it. Yeah, I got 7.9.
7.9. Okay, perfect. That's great. So that means you literally just took the upward forces, right? The upward forces were what? I'm just going to use cos over here. I use 8 cos 44. Okay. And I use 69. The downward forces must be T3. So I know it if they're in equilibrium, cos 44 plus 6 cos 69 should equal to T3. And if you just add them together, they should equal to T3, right? So let's check. You might have used the other sign. You might have used the other angle, this one and this one, but I just stuck with the 44 and 69. But the other one is right as well. So 8 cos 44 plus 6 cos 69 should equal to T3, 7.9. T3 is 7.904 and so on. And that's absolutely right, right? So this is a much easier version of the question. If T1 and T2 are given, it makes our life much easier. But if T2 and T1 are unknown and you don't know, and you don't know whether these are equal, right? You're not really sure. And you've got to somehow do like simultaneous, substituting stuff. It becomes much, much harder to solve the question. So this is the difference. In fact, this is like one of the most difficult questions for vectors that has ever come. Don't worry. So if you're good with this question, if you've understood this question really, then guarantee there will be like, zero other questions of vectors that will make you, make you want to kill yourself. Okay. Okay, I've updated the note and we will be starting the next chapter, projectile motion, on Saturday. I'm going to send you a worksheet of vectors, okay, probably today, of MCQs. There will only be MCQs. You don't need to like, theoretical stuff for that. You just need to get the answers and it'll just be very basic questions for vectors, addition, subtraction, vector resolution, nothing pretty long, okay? So make sure you do that worksheet and get it done before the next class, and then we'll start projectile motion on Saturday. Okay, perfect. That'll be all.